welcome back. I hope this chapter is completely clear to you by now. So let us discuss about few concepts. For this I have taken few problems from NCERT textbook, right, after the chapter in problems, and we'll discuss about few of these concepts one by one, fine, so that your concepts will be more clear now. The first question is, among the second period elements, the actual ionization enthalpies are in the order. Lithium will have lesser ionization enthalpy than boron, which will be lesser than beryllium, which is lesser than carbon, oxygen, then comes nitrogen, fluorine, and neon. So neon will have the highest ionization enthalpy. Explain why beryllium has higher ionization enthalpy than boron, and explain why oxygen has lower ionization enthalpy than nitrogen and fluorine. Fine, we'll go about this one by one. Fine. So first, during the process of ionization, what happens is electrons are removed from the outermost orbit, right? In case of beryllium, it has 2s orbitals, fine. But in case of boron, 2p orbitals are involved. So in case of beryllium, electrons are in the 2s orbital. What happens is s orbitals are more strongly attracted towards the nucleus, right? They're more strongly held by the nucleus. So it's difficult to remove electrons from the s orbitals than p orbitals, right? So hence, the electron to be removed from beryllium atom is an 2s or 2s electron, whereas the electron to be removed from boron is a 2p electrons. Now, since this 2s electrons is strongly attached to the nucleus than 2p electrons, more energy is required to remove these electrons, that is 2s electrons from beryllium, than the energy required to remove 2p from boron. Hence, beryllium will have a higher ionization enthalpy than boron. Next question is, oxygen has lower ionization enthalpy than nitrogen and fluorine. So we'll discuss about that now. In nitrogen, 3p or so in nitrogen, it has 3p electrons, right? So all these 3p electrons are in different p orbitals, px, py, and pz. Also, we discussed this while filling the electrons. According to Hunt's rule, what happens is you have to fill one electrons in each orbital first, and then go back and start filling the second electron, right? So in case of nitrogen, it has 2p3, hence there will be 3 electrons in each p orbital. But in case of oxygen, it's 2p4. So what happens? 1, 2, 3, and the fourth electron comes again back to one of the p orbitals. Suppose px has 2 electrons. So what happens is, in this case, there will be repulsion between these 2 electrons, right? So when there is already repulsion, it is easier for us to take away an electron from that atom, right? Hence, so what happens is, in nitrogen, these 3 electrons occupy different p orbitals, and in oxygen, 2 occupy the same p orbitals, and this results in increased electron-electron repulsion, and as a result, the energy required to remove fourth 2p orbital from oxygen is less as compared to the energy required to remove one from these 3p orbital electrons, because they are all different, right? Just one electron in each orbital. Hence, oxygen has lower ionization enthalpy than nitrogen, and fluorine contains one electron and one proton more than that of oxygen, right? So as the electron is being added up in 2p, so in this case 2p orbitals will have 2 electrons each, right? So so the increase in nuclear attraction, because there is an addition of proton as well, and this is more than the increase in electronic repulsion, and due to the addition of the electron, and hence it will have more ionization enthalpy than nitrogen or oxygen. Next question. Would you expect the second electron gain enthalpy of oxygen as positive, more negative, or less negative than the first? Justify your answer. So we know that electron gain enthalpy becomes more and more negative as we move from left to right, right? So now we are talking particularly about oxygen. So we'll discuss about it. So firstly, when electron is being added to oxygen, it will gain negative charge, right? So it will become from O to O minus, right? So energy is released when you are adding an electron to oxygen. So the first electron gain enthalpy of oxygen is negative. So now you add one more electron to this. So it's already in O minus ion, right? So when you add one more, it will become O2 minus, and the electron gain enthalpy is already negative. So energy has to be given out in order to overcome the strong electronic repulsions, right? Now there are more electrons and there is more repulsion. Thus the second electron gain enthalpy is positive. The first one it's negative, and the second one also energy has to be given out in order to overcome these repulsions, and hence it is positive now. So O minus will become O2 minus. Next, consider the elements boron, carbon, nitrogen, fluorine and silicon. So in these, the correct order of non-metallic characters. So when we talk about non-metallic elements, those are usually p block elements, right? So you have to give the correct order of non-metallic character, but that is increasing order. So we know that non-metallic character increases from left to right as we go across the period, right? So thus the decreasing order of non-metallic will be, that is fluorine, that is almost at the end, right? Extreme end, that is the rightmost, will have more non-metallic character than nitrogen. Then comes carbon and then comes boron, right? The rightmost will have more non-metallic character than this one, than the other ones. So again, the non-metallic character decreases as we go down the group, right? And hence, silica will have less non-metallic character than carbon, and hence silicon is less non-metallic than boron. And so in this case, what happens is F, N, C, B and S. That is the third one is the correct answer. Next one. Consider the element fluorine, chloride, chlorine, oxygen and nitrogen. The correct order of the chemical reactivity. So now they're asking about the correct order of the chemical reactivity in terms of oxidizing property. So we'll consider all the elements and go one by one. Fine. So the oxidizing character of elements increases from left to right as we move across the period, and it decreases from top to bottom as we move down the group. The same like the previous one. So what happens is, thus we get, since fluorine is the rightmost, fluorine will have more oxidizing character than oxygen, than the nitrogen, right? So when we go from top to bottom, fluorine will have more than chlorine, right? This all comes under halogens, right? And oxygen will have more than chlorine because the order is already like fluorine, oxygen, nitrogen, and then comes the chloride. So the correct order is fluorine, oxygen, chlorine and nitrogen. Fine. Next, what are the major differences between metals and non-metals? We discussed a lot about metals and non-metals and about the trends between the metals and non-metals. So these metals basically have S block elements, right? And non-metals are basically P block element. Fine. So metals can lose electrons easily. Since the electrons are in S orbital, it can lose electrons easily, but it's not easy for them to gain electrons. Whereas in non-metals, they cannot lose electrons easily, but they can gain electrons easily. Since the p orbitals are involved, they can gain electrons easily. Fine. And metals usually form ionic compounds, and non-metals it's covalent compounds. Fine. And metal oxides are basic in nature. This we discussed almost around the end of the chapter, right? And non-metallic oxides are acidic in nature. And now when we go from left to right, that is when we go from metals to non-metals, metals have low ionization enthalpy and they have low negative electron, they have less negative electron gain enthalpy, right? And towards the right, that is non-metals, they have high ionization enthalpy and they have more negative electron gain enthalpies, right? And metals are less electronegative and they're usually electropositive than we say electronegative. And non-metals are electronegative. Fluorine is the most electronegative, right? Atom. And metals have high reducing power and non-metals have low reducing power. Fine. So this is all about the chapter 3 and the discussion about the chapter 3 and the problems involved in it. As you can see, even these problems are very simple and very easy to solve. All you have to do is you have to just revise all these concepts and you'll have to just connect all these, the metals and non-metals, the trends, and you'll be able to solve it easily. And thank you for watching. If you are liking these videos, please don't forget to like, subscribe and like, share and subscribe to read my